Hello everyone. Today we are discussing about the properties which are related to angles in a circle. So the first property which is very important is angle subtended at the center by any chord or arc is twice the angle subtended by on the remaining part of the circle. Now we are saying that this is a circle and AB is the chord. We can also define that ACB, this is the arc. Or we can say this line AB has divided the circle into two segments. One is the segment ACB and another is the segment ADB. So this is one segment and this is the another segment. So here we are saying that the angle subtended at the center by the chord. So either we can say this is the chord or this is the arc and this is the angle which is subtended at the center, which is known as angle AOB. This is always twice the angle subtended by it, by this arc on the remaining part of the circle. Now this is the remaining part of the circle. So if we subtend an angle on the remaining part of the circle, then this is angle ADB. Suppose this is a point D. So this is angle ADB. So angle AOB at the center is always double the angle at the another part of the circle. Now to prove this, we can first of all join the point D with the point O or the center. We understand that this is the radius which is equals to this and which is also equal to this, or we can say OD is equals to OA is equals to OB, which are basically the radius in the case of same circle. Now angle ODA is equals to, now this angle ODA, suppose we take this angle as X. So angle ODA and angle OAB both are equal because these two lines are equal. This will act as a isosceles triangle. So ODA is equal to angle OAD, which is equals to basically value X. So this angle is also X. If we look at this angle, suppose I take this angle as Y. So in triangle ODB, the angle ODB is equals to angle OBD. Again, because these are two radius, so the angles which are corresponding to this must be the same. So here we can say the total angle ADB is X plus Y. X plus Y. If in case we go from point D to O and we extend this line to a point L. Now the angle which it makes, angle AOL, this is basically the external angle. This must be the equal to the sum of the remaining two angles. So this angle AOL is equals to 2x. This is this angle x and this angle x. Same way, if we talk about this angle, that is angle BOL, this is also equal to the sum of remaining two angles, that is 2y. So the complete angle AOB is equals to 2 of x plus y. So this is equal to twice the angle at the another part of the segment of a circle. Now when I am saying that this part of the segment of the circle, then definitely if I draw another angle at a point E, then this angle is also half of it, or I can say this angle at the center is double of this angle as well as double of this angle. That means that these two angles must be equal. This is another theorem or the property where angle in the same segment of a circle are equal. That means if these are the 2 points, this is one segment, and if I draw any angle in this segment, this is a point AB and these are points C, D and E. So all the angles, angle ACB is equals to angle ADB is equals to angle AEB. All these angles must be equal because these are on the same segment. If I take the angle on the another segment, then this angle is not equal to these angles. But this angle plus this angle will constitute a sum of 180 degree, which we have already discussed in our cyclic quadrilateral, that if in case we make a circle on a quadrilateral which comes under the inside the circle, then the sum of opposite angles must be 180 degree. The reason behind this is, if we draw a center, so this angle is definitely double of this, while this angle is double of this. So if the complete angle at the center is 360, then the angle made on the different segment, the sum must be 180. So here we can say angle ADB or any of the angle in the same segment. It can be ACB, it can be AEB plus angle AFB. The sum must be 180 degree. So the sum of this plus this is 180 degree. Then there comes the another property, that angle in a semicircle is always a right angle. If we look at the semicircle, we can say AB is basically acting like a chord, and we already know that whatever angle is there at the center, so the angle in the same segment must be half of the angle at the center. Here it is a straight line, so angle AOB is equals to 180 degree. So if we make any angle on the segment, in the another segment of the circle, which is on the semicircle, this must be half of this angle. Definitely the angle ACB is equals to 90 degree. So this is the another property which is related to angles, and in the next one we will discuss about the question based on it.